Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about the frequency and time period of a wave. So we start off with the following. We've got two diagrams here, A and B. Let's say it took me a second to collect both of them. It took me a second to collect A, it took me a second to collect B. Which one has the highest frequency? Which one is it? Is it A or B? Right, so in order to do this, we've got to define frequency. Frequency is equal to the number of waves per unit time. So let's put that down. Frequency is equal to the number of waves divided by the time. So which one do you think has the greatest amount of waves in a given unit of time? We need to count the number of waves in each case. So in A, we've got 1, 2. So 2, there's 2 waves inside A. Up and down equals 1 wave. For B, we've got 1, 2, 3, 4. So in B, we have a higher frequency. Why? I've got 4 waves here in 1 second, compared to A, which I've got 2 waves in 1 second. So B has the highest frequency. This one has the highest frequency. Okay, so let's just box my formula here. Frequency is equal to number of waves divided by time. So if I was to calculate the frequency of B, the number of waves, I've got 4 waves divided by 1. Therefore, the frequency is going to be 4 hertz. So the unit of frequency is going to be measured in hertz. So frequency, the units are hertz. Capital H, little z. Time is going to be seconds. So let's work out the frequency of A. So frequency is equal to the number of waves. I've got 2 waves divided by 1 second. Frequency is 2, and the unit for frequency is hertz. So we can clearly see that B has a higher frequency because it's 4 hertz, and A has a lower frequency because it's 2 hertz. Why? Frequency is the number of waves divided by time, where time is in seconds, frequency is in hertz, capital H, little z. You have to put down capital H and little z to gain the mark. Okay, simple stuff. Let's move on. Right, so test your understanding again. Let's say you're at the seaside, 10 waves go past you in 5 seconds. What is their frequency? That's you have a stopwatch, you're doing the timing. So frequency, you know, is the number of waves divided by the time. So frequency is the number of waves you've got. You've got 10 waves divided by the time, which is 5. Yes, this is the number of waves. Here is the time. And you don't have to convert time because it's already in seconds. So 10 divided by 5, it's going to be 2 hertz. Easy stuff. Give yourself a tick to feel good. Right, okay, now we're moving on now from frequency to the word time period. So the word time period, which is denoted by capital T. So if you see capital T anywhere, it means the time period. What does the word time period mean? The word time period means the time taken for one wave to occur. So the time period is equal to the time taken for one wave to occur. Happy with that? Right, so let's say we've got this oscilloscope trace. What is the time period for this wave? You've got to look at, first of all, each square. How much is each square worth? It tells me at the top here, each square is 1 second per division. So each of these squares is 1 second. Let's change the color of the pen. That is 1 second. So every single box is 1 second. If you want the time taken for one wave to occur, you've got to count the number of squares. So let's identify one wave. So one wave goes all the way up, back down, and there. That is one wave. How many squares is that? That is in total 4 seconds. Why? There are 4 boxes across, and each box is 1 second. So therefore the time period is equal to 4 times by 1 second. The time period for this wave is 4 seconds. Easy stuff. So the time period is the time taken for one wave to occur. Scrolling down, let's move on. How are the frequency and time period related? How are they both related towards each other? Well, the frequency is equal to 1 divided by the time period. Okay, so now there are two formulas for frequency. The first one is number of waves divided by time, and now the frequency is also 1 divided by the time period. So let's define the units. Frequency is still in capital H little z for hertz. Time period is in seconds. So we have two formulas for frequency. We have frequency is number of waves divided by the time, and also frequency is 1 divided by the time period. So we've got two different formulas here. You have to look carefully when you're going to use them. All right, let's test understanding. Right, so we've got the following diagram. Which wave has the highest frequency? Which one is it? So let's go with this one, A and B. We can simply glance at it. We know that B has the most number of waves in the same unit of time. So B has the highest frequency, and this one has a low frequency. Notice I'm going to use F to represent frequency. If the time period of a wave, here's the second question, question number 2. If the time period of a wave is 0.1 second, what is the frequency of the wave? Right, you've got to use the formula. Frequency is equal to 1 divided by the time period. Now, frequency is therefore 1 divided by the time period. It takes 0.1 second for the time period. Let's put this one here, 0.1. So frequency is equal to 10 capital H little z. So frequency is 10 hertz. And we've done two questions here. Make sure you understand it. Don't just follow me. Make sure you can do it yourself. Now, scrolling down, summary. We have the following points. Frequency is the number of waves per second. We've done that. Okay, right. Frequency is also the number of waves divided by the time. Yeah? Frequency is also 1 divided by the time period. Yeah? And the time period is the time taken for one wave cycle to occur.